All right, everyone, it's 11:15. Let's go ahead and get started. So we have a test on the previous um, if I haven't already said this, I have multiple choice and free response on it, but there's going to be less multiple choice and more free response. So yeah, I know. Covers from section 2.4 to all the way through chapter 3. Any other questions about the format of the exam? All right, and then format is the conference. Yeah, we'll after that. The map for exam. So, like I said last time, or over Canvas, wherever I said it, this is basically a review session for you. So, whatever questions you have, we'll talk about whatever we can in this class period, and then I have office hours tomorrow from 3 to 4. But outside of that, that's pretty much all the scheduled times I have where you can reach out to me. I mean, you can always email me, but that'll be about it. So I'll give it to you. What questions do you have? Go ahead. What's that? Yeah, got an example? Okay. Let me come up with a sufficiently complex one. So what if I have this function f of x equals two times the inverse sine of six e to the x squared plus 1. And I want to find the derivative. All right, so how do I start this thing? Go ahead, Cameron.
So we have to split it into two separate or
At least two. Yeah.
So we could start with g of x being 2 sine inverse of x.
Okay.
H of x being 6.
Okay. So yeah, that would do it in two functions. Oh, I mean, we could break it down further, but I think based on that's completely a personal preference thing. So if this were me, I'd probably do it in 2 steps. But you guys learned chain rule 2.5 weeks ago. Maybe you need 3. So it's totally up to you. Let's take a vote. You want to do it like this in these 2 functions, or you want to toss the third function in there? Okay, good and 2. So I mean, really, no matter which way you do it, as long as you do things correctly, you're gonna be okay. So if we do it in these 2 functions, now that I want to start taking the derivative, how's that going to look? No. The derivative of inverse sine is not inverse cosine. So the derivative of sine is cosine, but those inverse trig derivatives are very different. Go ahead. It is probably in your best interest to memorize them, but I mean, you can develop them the way I did. Yeah, it would save you time if you knew them. Almost 1 minus x squared. So that's that derivative. What's the derivative of h of x? I'm missing some stuff here. So when you take the derivative of, let's not say e to the x, let's say e to the f of x. So f of x can be some other function. Thomas, you have something? Yeah, go for it. 12 e to the x squared plus 1. I still think I'm missing something. Yeah, it should be 12x, right? So let me do this specific thing here. So yeah, 12x e to the x squared plus 1. If you're going to multiply, if you're going to take a derivative of this e to the f of x thing, so one thing we know about the derivative of e to the x or e to the anything really is that, you know, that's not going to change. Our derivative is going to not be equal to e to the f of x, it's going to contain it. But then because of chain rule, what else is this thing going to have on it? Yeah, multiply by the derivative of the inside function, which is what we did over here. So the derivative of 6 e to the x squared plus 1 is 6 e to the x squared plus 1 is. Thomas? Yeah, we do. Thank you. All right, so do we have all the pieces we need to finish the derivative? If not, what am I missing? If so, how do we finish? Okay, I got everything. So then we'll kind of, where do I go from here? How can I construct f prime of x? So it's going to be g prime of h of x, right? Times. Okay, so that's good. Now we can start filling that in. So what is g prime of h of x going to look like? Yep. And you know what? Just if I asked you to simplify this, I believe you could, but most important thing for me here. The exponential functions, I would definitely brush up what those look like. It's not only for this coming Wednesday, but just to kind of looking ahead to the mastery test, I'm going to give you, you're going to have 20 functions to take derivatives of in 50 minutes. So if you needed to, you could draw out the triangle and derive those, like figure out what the derivative of inverse sine of x is again. You could do that, but it would take more time than if you just knew it. Thomas? They're complicated enough that I'm giving you 20 of them to do in 50 minutes. So that averages out to about 2.5 minutes. Some will take you substantially less time than that, but some might take more. But I went through it this week, and I think it's a reasonable test. Yeah, I mean, some will be easier, some will be harder. The derivative, the mastery test?
Just the test on this.
Oh, it's hard to say because think of what we did in chapter 2. So what was, like, I think product rule and quotient rule were in there, right? We've pretty much done that ever since then too. So also chain rule, we've done that ever since as well. So I mean, a lot of what we've done with derivatives basically is just been stacking on top of each other. So like this right here, we did chain rule in the middle of chapter 2, but we didn't have the inverse trig and exponential. Hard to say. Really, the chapter 2 stuff is kind of just snowballing it ever since. Trying to think of what it was.
I'm looking through it, there's also like implicit differentiation.
Yeah, so we've still been doing that. I mean, in fact, I think the way that let's say we were trying to take the derivative of the inverse sine of x, I think the way we first went into it was we rewrote it as sine y of x equals x, right? And then you take the derivative of both sides, you get cosine y dy dx equals 1. And then you draw out the triangle and get the ratio small dash. So, I mean, implicit differentiation is something that we've kind of carried along. I think the next section is about related rates.
Mhm.
Um,
And after related rates.
the differentials and local linearization. Yeah. So yeah, those two things are very closely related. I think there's we went over a couple of those, at least a couple of those. That's nothing. We were on like 2 hours last week. People weren't there. The video is now in the exam prep area on Canvas. If you want to watch through it. I think we did like 15 examples in there, so there's probably some good stuff there for those of you who weren't able to go. Thomas? Me and you met. Yeah, well, you might have to. Yeah. So, in fact, could I use the one I just did, or is that too off the wall? Yeah. So what if I said I had y is the inverse cosine of so I'm kind of coming up with the top of my head, so if they don't work smoothly, let's look at something out of it. So the inverse cosine, unless anybody has Thomas, do you have like a concrete example you want to look at? Okay. So we'll go with this one and see where it leads. So I want to know what the domain is to this function here, the inverse cosine of radical 1 minus x. So how can we start thinking about that? What if I asked you about a much simpler function? What if it was just the inverse cosine of x? What's the domain to this function, this simpler one? 0 to pi, right? So here's what I know. Basically what I know is this. I need,
Is it 0 to pi or 0 to 2?
it's not 2 pi, I'm sorry. I need this thing in here to deliver values between 0 and pi. So what's the right way to say that? I think a useful thing to do would be this. I want to find where it equals 0, and I also want to find where it equals pi. And then from there, maybe I can piece together the whole domain. Any questions on why I wrote those two smaller equations there? So the top one is going to give us a value of, it's just 1, right? Just 1. This one's going to come out to be a little crazier. 1 minus x equals pi squared. Minus x equals pi squared minus 1. X equals 1 minus pi squared. Fine? I'm sorry, I just said domain here, didn't I? Meant range. Oh, so am I doing the wrong thing here? Yeah, I absolutely am. Gotta back up a ways. Right, so the domain of the inverse cosine function is from -1 to 1. and the range is from 0 to pi. Okay. My mistake. Any questions on that correction? It might be easier to think about it. What if we had y equals cosine of x? Clearly that range is equal to -1 to 1. Typically the domain is all real numbers, but in order for us to even have this inverse to talk about, we need to restrict it to 0 to pi. All right, so from there, can we, actually I can rewrite this a little bit. Basically what I need to happen is this. So how can I find the values of x that are going to get me in, put me inside that interval? First of all, is it even possible for me to get a negative number out of that expression in the middle? No, that's not going to work, right? So because of that, I can sort of make my life easier with this. Solve this inequality. So from there, what's an interval of x values that's going to make this work for us? It's actually going to be x is going to be, oh no, wow, what is happening here? Doesn't make sense either, does it? Because it can't be all positive numbers. So we know that x has to be positive. Actually, I'm not convinced of this either. Thomas? I replaced it with 0 because there's no way this square root expression here is ever going to give us anything negative, right? So it seems to me the domain is going to be between 0 and 1. But I'm not sure why solving for it this way didn't give that. So yeah, like I said, this is the problem we're trying to contrive one out of my head. We understand in term between 0 and 1. We understand why x cannot be negative. What happens if x is negative? Yeah, so then I get some number that's bigger than 1. And then I'm trying to ask what angle has a cosine that's bigger than 1, and that doesn't exist. So that's why x has to be positive. Why can't x be bigger than 1? Well, that'd be I'm asking why the domain is what it is, essentially. So keep in mind here, x value between 0 and 1. So then it wasn't a great example. Let me see if I can go back and get that one from the quiz from a while ago. Does anybody have that quiz with them? Oh. I don't remember which one. I'll go look for it. All right, cosine 3x squared. Yeah. Yep, okay, let's do that one instead. I mean, even though you've already done it, it's worth looking at again. So y equals the inverse cosine of 3x squared. So again, I'm only allowed to take the inverse cosine of values between -1 and 1, right? So because of that, this is what I'm looking at. I need 3x squared to be in between -1 and +1. The way that I did this in the solution online was basically this. I replaced this inequality here with this one. The absolute value of 3x squared is less than or equal to 1. Because if you have some value that's in between -1 and 1, that's another way of saying that, okay, that expression is within 1 unit of 0, which is basically what the definition of the absolute value is. I want the absolute value of that thing to be less than 1, less than or equal to 1. Otherwise, that inequality gets might be a little tricky how to handle when you start picking square roots and negatives. So from here, I can start solving for x. So I get the absolute value of x squared is less than or equal to 1/3, and the absolute value of x is less than or equal to 1 over radical 3. But if I want to translate that into a domain, if I have the absolute value of x is less than or equal to 1 over radical 3, what x values am I allowed to have? Right, so those are going to be the bounds. So there's the domain of the function. So any questions on where that comes from? That's that really comes from what the definition of what absolute value means. So let me, for now, replace this with just C. If I put this on a number line, and kind of look at these values, C is in the middle of that, right? So basically, how far away am I allowed to be from C? I could be 1 unit below or 1 unit above, right? That's what that interval implies.
Right.
So, and just, if you write something like this, the absolute value of x equals 6, really what that means is x is, the distance between x and 0 is 6. And since we're dealing with real numbers, that means that x can either be 6 above 0 or 6 below 0. So basically, I'm kind of using the definition of absolute value to simplify my inequalities here. Yeah. In fact, if that's a little mysterious for you, I'll give you another way to think about it, but that's essentially what I'm doing.
Okay.
It doesn't mean I'm not really taking it away. I'm just kind of absorbing it. Like I'm not really losing any information. But if I'm saying the absolute value of 3x squared is less than or equal to 1, then that means theoretically 3x squared would be permitted to be either positive and less than 1 or negative and greater than -1, which is impossible in this case, but that's what the absolute value means. So we got the domain. Let's say this, man, I think inequalities are just inherently more difficult to deal with. If that's tripping you up here, something else you could do is this. Try to find the boundaries. So solve these two equations, 3x squared equals 1 and 3x squared equals -1. So this is not going to find the full interval for you all at once, but it will find you any boundary points. So this one right here, hopefully it's okay if I just tell you that that gives me x equals plus or minus 1 over radical 3. Is that fair to say? This thing down here is not even going to work. So from those two equations, I got 2 boundary points, right? So from here, here's what you might be able to do. I can split up all the real numbers into a few intervals. So I know that negative 1 over radical 3 and positive 1 over radical 3 are in the domain, right? So now I got to figure out, is this middle area in the domain? Kind of like what we did in chapter 4 for looking at local extreme points. We can test some values, right? Is 0 inside the domain of my function? Yep, inverse cosine of 0 is well defined. Is negative 1 sounds good. Is negative 1 inside my domain? Yeah, inverse cosine of 3 is undefined. What about positive 1? No. So that means that I found this domain, all this stuff in here. Which takes a little more time, but only a little. I mean, whichever way makes more sense to you. But let's keep in mind here, the bottom line is, what is this argument to my inverse cosine function? And what do I need that to land in between for this to be actually followed? Anything else on this one? All right, well, what else? Good. Yeah, let's look at it. So the function is inverse cosine of 3x squared, right? First of all, what is the derivative? Let's just work it out, or work it out again. What is the derivative of the inverse cosine function in general? It's actually very similar to arc sine, except for it's negative. Yeah, so 6x over 1 minus 9x to the fourth, right? Okay. So in finding the domain for this one, that's the derivative of inverse cosine. Yeah. So what is going to cause this function, this derivative, to be undefined? Where the denominator equals 0, that's one case. What else? Yeah, so the denominator itself can be undefined, right? So not only do I need to keep 1 minus 9x to the fourth, I need to keep it away from 0, but I also need to just keep it positive. So Jordan, that might answer the question that you asked, is why it's not inclusive. Because so with the original function, so the inverse cosine, 0 is a part of that domain, right? In this case, whatever the x value is that makes that radical equal to 0 is not permitted because I'm dividing by it. The original right. Right, so let's see why. So Just for ease, I'm gonna do this. I'm gonna set this thing equal to 0 and then, sorry, was that Jordan? Okay, so I'm gonna set this thing equal to 0 and just find the boundaries that way. So I got 9x to the 4th equals 1. X to the 4th equals 1/9, plus or minus 1, no, sorry, not yet. 1/9. And then x equals plus or minus the 4th root of 1/9, which hopefully you just let me tell you that this is equal to 1 over radical 3. Maybe I should explain that. So the 4th root of 9 is equal to the 4th root of 3 squared, right? Which is equal to 3 squared to the 1/4 power, which is equal to 3 to the 1/2 power. So those are my boundaries, right? Plus or minus 1 over radical 3. So I'm going to draw a very similar number line to look at the domain. So I guess now I should probably check the endpoints. What happens if x is equal to -1 over radical 3? Yeah, I divide by 0, right? So not in the domain, not in the domain. Is 0 inside the domain? Yep. This becomes, yeah, dy dx equals 0, which is defined. So I still have this middle region there. I have all the values strictly inside that interval, but not the ends. And then I'm going to ask you to take my word for the fact that outside of there is going to cause a problem. Again, Jordan? Yeah. Do you have an example?
Almost like the column.
Yeah, you want to go over that exact one, or you want to take your chances with me coming up with one in 2 minutes? Okay, so let's say I have a cone. It's partially full of water. And let's say it's filling up. Let's say the radius of this cone is 10 feet. Let's say the height of the empty tank is 30 feet. Let's say I'm filling tank at 50 cubic feet per minute. Let's say the tank is leaking. This that alone. So it's filling up and it's not being empty. And I want to find what? Let's find the how fast water level is rising. Yeah, I think this should work. So how would we handle that? It's not.
Okay.
I was about to throw that in, but not needed. Thomas? 50 cubic feet per minute. That's how fast water is being put into the tank. I think I need to give you more information. Find out how fast the water level is rising. When tank is half full. Okay. So what information do we need? What do we already have?
Either,
Yep, what's the volume of a cone?
Air squared times height.
1/3 pi r squared times height. Good. We should probably figure out what I'm asking for. So I'm finding, I want to find out how fast the water level is rising when the tank is half full. So what is a good name for that quantity? The HDT makes sense. So we got, I'm not going to write them down, but let's talk about what variables we have here. We got the H, which stands for the water level, right? We got V, which stands for the volume of the water. We got R, which stands for the radius of the top surface of the water. All right, so we got a good equation for that. How can we keep going further? What do you want to do with that? I mean, they go, DHDT is one variable. So yeah, I mean, we don't have the means to find that yet. We could get there. What else do we need to know about the situation? Yeah, so is there a way we can unite the radius of the water level to the height of the water? Yeah, I mean, that's going to be, so if I just draw a triangle for this empty tank, I told you that the empty tank was 30 feet tall and had a radius of 10 feet. So what does that mean about the way the height and the radius are related to one another? Radius equals 1/3 of the height. Now I would like to make a substitution to my equation here. So what variable should I, basically I'm going to get rid of one of my variables, either radius or height. Why would I want to get rid of radius? I could do that, but no, here's the question I also want to ask. Thomas, you have something? Okay, let me ask this. Why do I want to keep H as part of this equation? I want to know something about the rate of change of height when I'm done, right? So I'm okay to sacrifice R, but I really want to keep height intact. So now I have this equation, which simplifies to 1/27 pi h cubed. So I got my volume now. Instead of having to do an implicit differentiation with a product rule, now I have this thing all in terms of a single variable. And it's the variable I really care about. Any questions here? All right, now that I have this equation, what should I do with it? With respect to what variable? So that's dV dt equals what? I don't need to do quotient rule.
195.
And let's unpack that. Why don't I need to do quotient rule? Yeah, denominator is constant. So I mean, you could do quotient rule, but it would probably be obvious pretty early that it's a little too high tech. But it would work. It absolutely would work. All right, is that the full derivative here? I absolutely did. So that's my derivative, right? Do I have all the information I need? Do I know dV dt? dV dt? I know dV dt. I gave that to you first. Yeah. So what that kind of reminds me of something here. It's really valuable to have variables, to name the variables, make sure we know what they are. So yeah, V stands for If V stands for volume and T stands for time, then dBdt is the rate of change of volume per unit time, right? And then once you know that, you can start looking at units. So all my lengths are in feet, which means my volume should be in feet cubed. All right, so I have dBdt. I want dHdt. Do I have H? What is it? No. I disagree with 15 as well. You can get it, but here's the thing. I would not say this tank is half full. If it was a cylinder, I could definitely do it that way. I got to know a little more. So I think so, but how'd you do that? How'd you do that?
Just,
Okay. Impressive.
but you can also do,
Yeah, how do we solve for it?
you can find the volume of the entire thing and then just divide
And
that
it-
by.
Yeah, I like that. So the volume of the full thing is going to be 1/3 pi times 10 squared times 30, right? Which comes out to a number that you will tell me 1,000 pi. It's nicer than I thought I was going to be. So what's the height going to be of the water when the volume is 500 pi? Oh, that's nasty. I got two variables.
Use the,
Yeah, absolutely. So we know that. Oh, why did I use that equation? Oh, that's silly. So I can easily I already wrote this this simplified equation. So 500 pi equals 1/27 pi times h cubed. What's the cube root of 500 times 27? Yeah, 23.8. Sebastian? That came from this simplified equation for volume. So we started with the volume of any we did something specific to find the volume of this one. Thomas? Because, yeah, somebody else answered that. Why don't I do that? Trying to find what's half full, right? I'm trying to find the water level that gives a half full tank. Do we agree with 23.8? Yeah, I was sort of expecting 20 myself. All right. Oh, I know why. Okay. So 23.8 is the height, right? So now I believe we have everything we need. So solving for this, we got 50 equals 1/9 pi times 23.8 squared times dHdt, which I really care about. I am getting dHdt equals 0.253 feet per. That was a good question.
so if you have the full, where would that
So let's say it was leaking.
be?
So let me answer it this way. All we're doing is filling up the tank, right? It's not leaking. What did we do with that information for the tank filling up?
Use it as dB.
Right, because dBdt stands for the change in volume, right?
Okay.
So if there was a leak,
I'd have to find the difference.
right? So if it was, let's say it was leaking out at 5 cubic feet per minute, Then what would that do to my,
Subtract.
you just subtract. So yeah, knowing it would be negative is important. So yeah, the DVDT being positive implies that water's coming in. Being negative implies the water's leaking out or leaving somehow. A lot going on in that question is valuable, I think. Pardon?
Am I able to ask that? Here, potential types of related grade plan should be.
I would focus on the ones we've done on quizzes, homeworks and the that I think I promised last night that I would not be giving any like off the wall geometries. And the ones we looked at, I mean, I think so the probably the most complicated geometric shape that I had you look at. But in terms of like one thing I'll have to is fundamentally the same as anything else we've done. One thing formal job is finding all the variables and stuff. Variables are one of the situations. It should be most of this we can out. And there are things one thing that I think is a good idea just in general. Even though you've already done the homework questions, even if you might have got 100% on the homework and the quizzes that go along with this stuff, doesn't mean you still totally understand the things you did back then. So I think it's a good idea to look at those things again and not necessarily work through everything all over again, but at least make sure you can kind of convince yourself that you understand why, how you got from A to Z and all the steps in between. I saw a hand up over here somewhere. Okay. I might ask you to stay after because I got 3 minutes. Yeah, I don't know if I'm going to be able to answer the questions in that time. So I'll go ahead and wrap up here. If you want to stick around and talk to me for a bit, you can. Otherwise, I have office hours tomorrow online from 3 to 4. Or email me if there's something you need. Otherwise, we'll do this on Wednesday.